All right, welcome back everybody. It is 10:30 Eastern Time, so we're going to go ahead and get started with our next session of the day. This session is going to be a response to the reverse pitches that we've heard so far. We're going to have three different panelists here with us today. We're going to start off with Karush Ravan from MIT. We'll go to Mark Christian from Intel next, and lastly, John Edens from ThermoGeo. So, all right, Karush, over to you. Let's get us started. Thank you.
Thanks, Hannah. All right. So I was asked to begin the slides with kind of how our work relates to the challenges mentioned throughout this workshop, and it's we try to mainly work on digital twinning and asset optimization, and in a spirit of continual learning, which is a critical part of any utility culture. Really, none of the work is ever complete. I thought I'd start with the the latest AI hype cycle chart, because that's kind of relevant to a lot of discussion that has been talked about so far. In that the natural language processing and computer vision that has been really trying to kind of preliminarily deployed in a lot of utilities in recent years are kind of getting to the mature stage where a lot of their limitations as well as the benefits are kind of becoming clear. And as you see from this hype cycle, these things does take multi years to really develop and deploy. Explainable AI continues to be a focus, and then the thing I'll talk about a little bit more in this presentation is that deep reinforcement learning is kind of starting to reach a peak and is on the rise. All right, so digital twins, just want to mention, there are more than just one digital twin. It's not just for prediction of operation. You can have asset digital twins, human operational maintenance and compliance digital twins. So it goes beyond that. But about 90% of the work in particularly nuclear energy sector on digital twins is really trying to use, a 20-year-old technology to predict basically how valves, piping, cores, in general behave, and try to use that data and apply AI to as typically surrogate model to do that predictive maintenance. And what I'll talk about is some of the advances on this front of predictability can that definitely give you the step change you're looking for in your organization. All right, so in terms of the specific AI activities in my group, we work on fuel optimization. I'll have a few slides there. On the O&M side, I like to always break it down to different parts of a plant. So a typical, well-run plant currently today, has over 400 people, and there's, there's a lot of people work on loss prevention and engineering. And even if you look at next generation of nuclear power plant, you're talking about still, a few hundred people expected to work there. And really, when you look at cost targets where you want to be, we're talking about you want to be reduce it to 60 to 75 people. So AI really has to play a big role on that. On the construction and scheduler, really we're working on trying to modernize that part of nuclear power development. But the common theme in our work is really a mix of domain knowledge and data. Again, that's where I feel that AI can play an important role. All right, so now to the fuel engineering digital twin example. What you see here is a quarter core of a pressurized water reactor. Every square represents a nuclear fuel assembly. And there's about 264 fuel rods in there. And the color here shows kind of the relative power that these assemblies operate in the core, and they also kind of is correlated to the age. And what you see here is that there's a lot of this is a software that some nuclear utilities use, and there's a lot of constraints and objectives that that you have to meet. There's a lot of rules that the engineer has to do in order to do this fuel design. And with this software, you can use the mouse click to move assemblies, or automatically have the software kind of shuffle these assemblies and pick different enrichment patterns and different specification for these assemblies. So it becomes a big kind of problem. And when we see that problem, we can get some inspiration from actual use of AI in gameplay. And this is where some of the work with Google DeepMind, where they found that they were able to beat world's most experts in gameplay. It's something they thought they maybe accomplish in 20 years later. And the opportunities also was very good at MIT, because right now MIT, the computer science department, has actually moved to its own college, given we recently got a big investment. And so we looked at, can we make this fuel optimization problem a little bit more streamlined and more efficient using AI? And so when we look at this challenge, the first thing you got to ask yourself, is really AI useful, or maybe we should just look at in other algorithms? And specifically with this fuel optimization problem, you look at the possibilities. We're talking about something astronomical, 10 to the 64 possibilities. So really, it's not, you can never find the global solution, how big of a computer you use. The other thing is that it's really a problem that's hard to explain, and that's where really, when you have those problems, AI can be helpful. So if you take two different fuel engineers, they come with different core patterns, and you can't, you ask them, how did you arrive for the answer? They can't really explain it to you, and this is where AI can be used. Yeah, of course, the challenge is that even if you purely base the whole process based on AI, then if you have even one out of 50,000 rods failing during operation, that provides a huge enterprise risk for your system. The other motivation is that right now utilities, again, to cut down costs, they're looking at different vendors, different fuel vendors. They're looking at changing their cycle length. Potentially new fuels can come in, and this is where those engineers not going to have the expertise to apply their knowledge in there, because this is all new. And again, really this motivates to have some kind of a AI technology that's able to do continual learning and be a efficient optimizer. Okay, looks like I'm back in sync here. The other feature of this problem is that the number of constraints is a lot. All right. Maybe I'll ask Hannah to click through, since there seems to be a big lag. The other feature of this problem is that you do need some kind of a a stochastic optimization, because you don't really can define your objective function. And that's where recent advances in AI, like proximal policy optimization, like PPO, can be useful. It's also very much parallelizable, and as you see from here, the whole process does involve in continual learning, and that's what you really want to solve this problem. Next slide, please. Some of the things we learn is that with this, applying reinforcement learning just blindly to the problem is just not going to give you the results you may be looking for. And really looking at applying reinforcement learning to really learn the rules that a fuel engineer follows becomes a more effective option compared to just using traditional or more advanced stochastic algorithms. Next slide. And as the problem becomes more realistic, and as you want to improve the fuel cost further and further, what we see is that you can you have to go back and incorporate as much domain knowledge and to look at more hybrid algorithms to really see the gain, because as the problem gets constrained, there's less opportunity for the reinforcement learning to learn. Next. And this is something that we've seen compared to other efforts in this area, where people try to use pure RL methodologies, and they haven't really shown much success. In our case, we actually used what's acceptable licensing methodologies to actually do the core design. So we didn't actually create the surrogate for that, and had actually reinforcement learning guide that process. And there's also other application of this you can apply for PPO. You can look at spent fuel management, which involves a lot of criticality safety search. You can look at outage management, where you're looking at dose minimization, where there is a lot of decision making involves, where there is not a black and white answer, where RL can help. Enterprise risk and asset management is always involve a complex stochastic process. The other advantage is that reinforcement learning does hold a memory. So in case of power disruption and everything, the agent can continue on and do the continual learning process. Next, please. All right, so now moving on to operational twin, and this is where the grand challenge of really digital twin is how to represent reality. And I think a lot of the utilities have already mentioned these two grand challenges really with that, is that you need sensor data to mimic reality, and there's also unknown failure modes, and this is some of the work that I've been working on how to address basically these challenges. And what you see here is that next. Yeah, what you see here is that this is a depiction of one physics. So this is fluid mechanics, and on the bottom is large eddy simulation. On the top is some advances in computational modeling, and really what when the reality that you're trying to, if you imagine the reality is this tree, and if you're applying the computational fluid dynamics, what you're going to see is just the tree trunk that you're going to model. That's how much computational resources you have. And really, the last 5 years, we've been able to demonstrate techniques that are able to actually capture more of the reality without increasing that computational cost. And that's where bringing those type of techniques into power plant operation, because at the end of the day, the fundamental physics that governs really operation maintenance is your failure modes for your pipes, pumps, valves, and heat exchangers, and this is where bringing that domain knowledge and combination of AI can really help. Next slide, please. All right, so now to that unknown failure modes, and how do you address that? Here, what you see in the graph here, the green line is, you can think of it as what reality is, and the blue line is what the state of the knowledge is, and then the uncertainty represents the kind of the light blue shading. And really, what to really get benefit from any type of AI implementation, you have to kind of reduce these uncertainties as well as improve your domain knowledge expertise. But what happens is that how do you make sure that you can actually capture the reality? As you can see in some cases, with the calibrated ML model, we're not capturing the reality, and that always comes back to how are you treating unknown unknowns. And there's a lot of advances in understanding of how to model these chaotic modeling, which is really fundamental on underlying physics behind weather forecasting, which is extremely important for utility and asset management. There's also, black swan event modeling. Recently we've been applying some of the frameworks that have been developed at MIT, like SDPA, to fusion power systems. There's no fusion power system existing. How do you go about modeling that? Nuclear Regulatory Commission has used similar techniques for digital instrumentation controls that plants are recently being implementing them. There's also, you can think of red team, type of approach to kind of try to avoid, situations that we've seen with California and Texas recently. There's also, the data experience and sharing is fundamental behind, improving your AI predictability and overcoming that is very important. In nuclear side, we have something called PERT, which is Phenomenon Identification Ranking Table. Is another way of trying to address, what are your unknown unknowns. Next. And of course, the whole field of explainable AI is fundamentally based on that unknown unknowns. Next. And so if you answer these uncertainties, really, then you can go about and answering that question of what sensor data do you actually need to have the effective digital twin. But unfortunately, what you'll see is that at the end of the day, and I've seen think one of the utility presentations that they would like to, address some of the safety significant things in their nuclear power plants. The nuclear regulator, on the other hand, actually guides you to not use AI or any surrogate modeling for those safety significant things. But where the regulator is coming from, it's really revolving around how do you know about your uncertainties and how do you know about your unknown unknowns. So you have to really take care of that before you can have a successful digital twin deployment. Now to the last slide. I want to just mention that in typically what utilities do, they try to expand their portfolio. The digital asset can be as important as the physical asset. Cybersecurity protection is always critical to address. And really, the whole AI adoption requires significant investment, and that's because you have to first know what is the value that you're trying to find. You got to do a very detailed economic assessment. There are softwares out there, including EPRI's TagBit. You got to understand what are the export control limitations, particularly when you talk about nuclear technology. What is your computer resources? How can you sustain funding, and how do you do the effective collaboration? So this whole thing becomes a very multi-year large investment where you need really central organization. I want to call it like an EPRI-like type of organization that really try to organize your efforts. And I'll end with this, that continual learning has really made the nuclear power plant safest really form of industrial technology. This is a graph from OSHA showing that nuclear power plant operation is safer than if you're at real estate, and really that continual learning is a critical part of that. And the latest AI technology is based on continual learning, and we can really leverage that to really reduce also the cost of energy production, which is a critical aspect of society. All right, with that, back to you, Hannah.
Great, thank you so much, Karush. Before we move on to Mark Christian, I just wanted to remind everyone to please post your questions and comments in the Q&A and ideas tab. We should have time at the very end of this session to go over a few of those questions. All right, over to you, Mark. Thank you.
All right. Thank you, everyone. I'm going to talk a little bit today about using AI to automate inspection workflows, specifically asset inspection workflows. Just a little bit on the summary of the presentations that were given. What you'll see is what we've been working on over at Intel is we have some capability around asset management and digital twinning, really on the data management and cybersecurity, but we're still building a solution. So not all of them align essentially what we have today with some of the reverse pitches that were presented, but I'll kind of give you an overview of what we're doing. All right, so before we get into specifically what we're doing I represent an organization called Intel Geospatial at Intel. Intel has a whole portfolio of solutions in the energy sector. Some of the things that we're doing around, say, digital transformation and data center is actually virtualization of substations. But where we kind of sit in the group that I represent, Intel Geospatial, we're really focused kind of on the situational awareness aspect of managing utility assets. And what we've built is an open cloud-based platform, runs on the Amazon or AWS infrastructure. And it's really a platform to bring all the data together, all the visual data that utilities are collecting today to manage their field assets, and essentially visualize that data and then apply AI algorithms to it. So what type of data are we talking about? There's been a lot of kind of geospatial capabilities transforming the industry. A lot of the other presentations have been focused on other types of sensors that are on the network, SCADA and other things, waveform analytics. Where we've been focused is really on kind of, you could think of it almost like the visual data that the human can actually view a photograph, a laser scan, and we're seeing a lot of these sensors, right, just proliferating. Whether it's the microsatellites that are being launched, so we can basically scan the Earth at faster refresh rates than we ever could before. The drones that people are using to inspect assets, whether the transmission towers or distribution poles, cell phones. Everybody, that's the most widely used sensor that we have today. Is basically everybody has a mobile phone in their pocket and they can take pictures. But we're also seeing that on cars and other devices. And then there's been the rise in cloud computing and really the game engine visualization that Karush talked a little bit about. And right, the rise in artificial intelligence, not just the actual models themselves, but really a lot of the tools to build AI. And so what we looked at is, how can we kind of help move the industry forward and take advantage of this? So our platform really does three things. It helps you bring all this kind of sensor data together into a data lake environment. You can visualize it using essentially game engine-like technology in a web browser or on your phone. And then we can apply AI algorithms to this data to extract insights. The picture on screen is showing some AI analysis that was run to detect vegetation, buildings, and vehicles on basically aerial imagery collected by a manned aircraft. And this one here is showing some AI on both aerial imagery and LiDAR data. And the next one, some AI algorithms that have been applied to essentially photos of distribution poles to identify certain components. Now, one of the things that I'll say is at Intel, we're developing a lot of this AI ourselves, but we don't believe one company can do it all. So we've developed a framework for others to deploy AI models, orchestrate them, to basically chain them together to solve new problems. We've focused on some specific things in energy and utilities around inventorying assets, identifying specific defects, such as you kind of see in this insulator string, doing things like AI on LiDAR to classify it and determine proximity of vegetation encroachment. And then we've done some other things around leak detection, specifically in the oil field upstream area. So specifically in electric utilities, we have been focused in the T&D side of the business. So looking both at transmission and distribution assets, and really two key use cases for maintenance of these assets. First is just the vegetation encroachment, right? It's one of the largest O&M spends for any utility. And then the other aspect is really the comprehensive visual inspections that are required from most public utility commissions, whether you're operating transmission infrastructure across the nation, or you're a rural electric co-op, working in a very smaller locality. Just a couple things on LiDAR that I'll talk about. And for folks that don't know what LiDAR is, it's basically a laser scanner. It's usually, it can be mounted on a plane. It can be mounted on a vehicle. Even the new iPhone 12 Pro actually has a laser scanner in it, so you can do close-in laser scanning. And what we looked at is, what are some of the key use cases and challenges that are basically in the industry. And this is a recent poll that from a T&D webinar. And what you'll see, right, the use case is really focused around vegetation management, right? Obviously design and engineering. A lot of that LiDAR data is utilized within CAD tools like PLS CAD. And obviously the 3D modeling and digital twinning are kind of the top use cases. The things that people are struggling with, you can kind of see here, is actually getting analysis out of this data. So analyzing it properly, just managing it because of its large size, the cost of acquisition, and then some of the things around actually classifying this data, taking a raw point cloud and turning it into information that actually can be analyzed, whether that be AI or otherwise. Just a couple of examples of some things that we have been working on. So when we talk about LiDAR, there is multiple ways to collect this data. One of them is from a manned aircraft, and there's a type of LiDAR called Geiger mode LiDAR, and this is flown at night, really high altitude, 16,000 feet. You can basically map an entire city, like a large metropolitan city, in an evening. Now, massive amounts of data, but you've got to turn it into something that's usable. So what you'll see on the right-hand side is some of the work we've been doing here to automate the classification of this LiDAR to basically say, hey, this point represents a building, vegetation, a conductor, a pole, and do this at massive scale. So the inference that we've been working on, we're able to classify this type of information for, say, a U.S. city of up to 1 million residents, right? We can do this overnight. So essentially, you can have data that's ready to work with it in a very short period of time. Just another example of what we're doing, the terrestrial type LiDAR capture. So this is vehicle mounted. You've probably seen, everybody's seen the Apple or the Google cars driving around. There's a lot of service providers that are doing this type of work for utilities, right? It's really is creating a digital twin as far as reality capture is sometimes the way it's called, right? Actually seeing what you can see here, the conductors, and you can see the poles. And so we're able to classify this type of LiDAR as well with the algorithms that we have been developing, once again, in a very short period of time, makes it usable now for analysis and use in other tools. Just a couple things that I'll mention is, the sensor technology is rapidly advancing. A lot of people have heard about, right, using drones to do asset inspections. This is just a little snapshot here of a new payload. It's a multi-sensor payload. It does LiDAR. It does basically digital photographs, so what we call red, green, blue imagery. It also will do thermal imaging. And what we get out of it is what's called the colorized point cloud. So, true reality capture is the way you can think about it, but it's still not necessarily usable for analytics because we can't extract specific features or specific objects out of that. So this is where this data needs to be classified. And this next slide just shows kind of an example of some of the work we've been doing with UAV collected imagery. So the image on the left would be a raw point cloud, non-colorized, and then on the right you'll see basically the results of running the inference on that, where we can actually start identifying specific structures and vegetation, both at different proximities, high, low, and medium vegetation. Something that that we really see that's just happening is this, right, mixed media or sensor fusion that's happening. We just saw that with the example of that new payload that came out for UAVs. This is being collected terrestrially today. A lot of this is being collected, both imagery, photographs, as well as LiDAR data. Really, where the power, I think, for what we'll be able to extract from this data and apply AI is when we are able to fuse this type of data. This is a lot of work that we're doing at Intel. We have a division called Mobileye that is assisted and autonomous driving division that is using camera and LiDAR technology for basically, most people have probably seen it today. You get your automatic braking assistance, lane change assistance, right? Most modern vehicles now have that on as standard kind of functionality that is available from all the different sensors that are on it. Combining those sensors, now we have this opportunity to really extract a lot more information and analytics from the data that's collected. Just a little bit about what we're doing on LiDAR. So we've focused on some key use cases. The vegetation encroachment is one. Inventorying assets, so right, actually determining, hey, what poles have transformers on them, fuses, reclosers, different things like that. And we've been able to develop some algorithms that classify this data into standard, what we call standard classes. These are from the American Society of Photogrammetry and Remote Sensing. This is kind of the baseline, right? It's the baseline building blocks to do analysis. Most utilities, when they utilize LiDAR data, they'll go a step further. They'll call it feature coding, and not just recognize a conductor, but we may recognize different conductor types. And so what we've focused on at Intel is really, hey, can we kind of tackle the baseline, the large scale problem by creating these core classes through our platform? We really see this is where others come into play to kind of build on top of that to extract the additional features that are required for specific use cases. And this little visualization here just shows an example of what we've been doing with our platform, and basically what's accessible from a web browser. What you'll see here is a LiDAR point cloud overlaid in a basically a kind of like a 3D virtual world, and you're starting to see the different layers that are extracted. So we see the conductors and poles, we can see the vegetation, road, buildings, and then at the end of the day, the encroachment proximity analysis that's done on vegetation. So that's kind of like an end output that would be for reporting to actually help with maintenance and tree trimming plans. So what I'll say is I'm just gave you a high level overview. If you want to really dig in and learn a lot more around what we're doing specifically around AI and LiDAR data, we did a presentation just a couple weeks ago where we had our head of AI at Intel deliver this, and it's publicly available to everyone, so you can dig in and learn a lot more of the kind of mechanics and some of the algorithms that we've developed. With that, Hannah, I will hand it off to you and let our next presenter take the stage. So thank you very much.
Great, thank you so much, Mark. All right, guys, just a reminder to please use the chat to ask any questions. We will have some time, it looks like, at the very end to get through a few of those questions. All right, so we are going to move over to John. John, go ahead and get started. Thank you very much.
Great, thank you. Hi, I'm John Edens with Theorem Geo. So let me go to the first slide here. So we were asked to basically, based off the various presentations that have been done, identify where our solution may or may not come into play. So we've all represented our data in the similar grid. In order to gear my presentation in the reverse pitch format, what I've done is I've modified that previous slide somewhat and tried to categorically address some of the various, I guess, challenges that the utilities have presented as being problematic throughout the throughout their pitches. And what I've done here, O&M costs omnipresent as an issue. NRECA and PG&E, we're talking about field data capture and being able to culminate the information. Vegetation management, obviously a big concern. Data access and management, visualization and virtual reality, and artificial intelligence. So what I'm going to do is first I'm going to talk about our tool a little bit, and then I'm going to jump into specifically how our tool CartoVid can help each of these areas with some form of resolution. So what CartoVid is it is a video and photo platform that allows for the ingestion of video and photo data that's geospatially centric. So again, it's a repository for all videos and photos. It allows for easy searching of media by either attribute or location. There's a lot that we won't get into today, but as far as again, this is a web-based platform off of the Google Cloud platform, the GCP. So it allows for easy collaboration, annotation, and sharing of information. We're able to create measurable 3D data sets from nearly any video segment, very much in line with the previous presentation from Intel. on LiDAR data. We're able to do that with the videos from nearly any video that we've captured. Ultimately, it improves situational awareness and safety, which is paramount and something that all utilities strive for. Every organization strives for, but utilities seem to be particularly geared towards that direction. Reduced O&M expenditure, and then ultimately offering a audit trail. Again, secured cloud environment, Zoom capabilities for all videos and photos, and really from a platform perspective, eliminating silos and being single-threaded, the ability to share this information. We'll get into all this throughout the presentation as it is directly addresses some of the concerns that were brought up. So let's see here. So what type of sources do we collect data from? Aerial patrol, which is predominantly for any organization that's got transmission assets. Helicopters are heavily used, so mounting the helicopters with various forms of video cameras and such. We've aggregated a lot of data. Drones, terrestrial, aerial, aquatic. We've actually recently done a project with one of our large customers on a subterranean zone, mapping out some culverts around one of their facilities. Dashcam data, action cams, and then we've got an iOS and Android app coming out in the August timeframe for, again, further enabling data capture. To give some idea of the types of video that we're collecting, HD, various formats of HD, infrared, and then multispectral, all of which play into the presentation somewhat here. So again, just so you all can get an idea contextually of what we're talking about here, this is a transmission, forgive the large black X's on things, but we didn't want to show certain information, but this is transmission veg for a utility organization, oftentimes has the budget to pay for these helicopter flights, but there's lots of other organizations inside of the utility that can benefit from having a seat in that plane. And really that's, oh, I'm sorry, give me one sec. Looks like the slide may have changed. Okay, here we go. Yeah, so in this specific example, vegetation purposes, again, was the intent of the flight, but asset protection definitely benefits from seeing that there's an encroachment there. That deer stand, something needs to be done about that. Again, for transmission purposes, just trying to show some value there. For distribution purposes, generally speaking, distribution tends to be, when it's above ground, closer to a road. If it's not closer to a road, it's accessible by drone or some other form of sensor capture. But being able to drive around and with the dash cam and capture data that is useful to the organization holistically, and the organization being able to go in and see where they've captured information, see various iterations of the information, and making one drive benefit the enterprise is ultimately the aim here with the tool. And again, we'll get into specifics here in a minute. I'm just trying to contextualize the tool before we do that. And then, of course, we've been very active in, we've not been as active as the hurricane season or the fire seasons, but we've been very active in specifically the hurricane response efforts with some of our large customers here in the Southeast as it relates to going out, capturing data for the damage assessment process and being able to correlate where you've had damage with what that specific circuitry is, and being able to offer your restoration crews some insights into what they're stepping into, and enabling them to better be prepared for the situation and for the restoration effort. All right, now to get into kind of thematically what the reverse pitch of this. So how does our tool help with O&M costs, data access, and management? So again, having the enterprise data repository for access and management is a great tool. We know that it's a large challenge when you get into some of these really large IOU organizations and even smaller ones. There's a lot of concern around cybersecurity and just like getting data into your system or getting access to data and then being able to share that data is a big challenge. our tool addresses that, which we'll get into in the next slide. And then data capture, enabling the ingestion of data from things that almost everyone has, such as a cell phone. Being able to ingest drone data, being able to ingest helicopter data, being able to ingest data from almost any camera is valuable. So again, you'll see down here on each of these slides sort of the point reactions to some of the specific concerns from PP&L, PG&E, Southern Company, things like that. But I'll jump into the next slide here. Wait, I'm sorry. Yeah, sorry, there's a delay on the slide. So this is what I was just reviewing. Let me get past this. So here is just a screenshot of the platform. So ultimately what it does is, again, cloud-based platform, allows for a lot of data to be loaded and ingested into the platform and then shared with the utility and anyone within the utility that should have access to the information. We've got easy to upload process on the front end, on the web-based application, mobile application coming out in Q3 August timeframe. And then over here to the right, you could just see where your data's at. We've got various search capabilities against the metadata itself. So this just gives you an idea, overview of how the data is loaded into the system and how the data can be disseminated. And people can see where we may have information that's relevant to what it is they're working on. All right. So as it relates to artificial intelligence, so there is a tremendous amount of value in, similar to the LiDAR data and being able to discern where information's at, the video data being spatially correlated, much like a photo would be as well. Oh, sorry, let's see that. Okay, here we go. The ability to run AI models, various object detection models against the video, have the video watch, or I'm sorry, have a computer watch the video, and I'm air quoting here, so it can make some determination of, hey, we see transformers here, we see lights here. This screenshot was from a street not too far from me here in Charlotte, North Carolina, one of our first object detection runs where we, detected where the transformers were at. We detected where the street lights were at. And then we subcategorized street lights, sodium vapor or LED. There's a tremendous amount of opportunity and future in that AI space from the object detection realm. And it's really fascinating and limited only by what we can dream up. So, this is exciting stuff. I'll move next into vegetation management. Again, so you've got comparative spectral analysis, and I've got a slide representative of that. And then we've got NDVI analysis. NDVI is tried and true, historic, very science-based founded. Comparative multispectral analysis is premised on the same concepts as NDVI, but it's different in that we're utilizing it. We're not having to do the post-processing capabilities that or make NDVI as beneficial as it is, but it's still, in our test cases, has proven to be very valuable. So as an example here, so this was a drive down the street in Cary, North Carolina, where we've got a multispectral camera just on the dash. And, a lot like Sesame Street used to be in the days of yore, one of these guys is different. If you notice that we've detected here an unhealthy tree, and all this is basically the chlorophyll return signature. This is a lot like how a butterfly or a bee may see the world. That's what these multispectral sensors do. And, the chlorophyll return for an unhealthy tree is different than that from a healthy tree. Fundamentally, that's what it is we're looking at here. So, the chlorophyll return, the spectral return that this specific multispectral sensor is picking up for this tree was different than for the others. And that tree was, in fact, unhealthy, which is, we'll get into this. NDVI, almost anybody that's doing any analytics in the vegetative space has probably delved into this realm in some form or fashion. it's got its genesis from military usage, but ultimately NDVI is really, fundamentally streamlining the information so that you get, a -1 to a +1 value, and whatever strata or layer in between -1 and +1 normalized video or photo data may fall into, you're able to universally ultimately delineate plant health. So again, in having all the video data and the photo data, being able to run these analytics against this information from a vegetative health perspective, is great. While in this specific instance, the distribution lines are over there to the right, and this is a short, dumpy tree. It's not really any threat. Let's say it was a tall tree and it was in fact over by the distribution circuitry. That may be something that you would want to go tackle before you actually get to its natural, vegetative cycle, be it 4, 5, 7 years, whatever the case may be. Next slide here. We are actually incredibly excited about this aspect of the tool. So we've got what we're called CartoCloud. It's patent pending. It's really enabling us to generate from any or nearly any video that we've captured in the platform, be it drone, helicopter, dash cam, these 3D point cloud environments that allow for one to analyze, manipulate, and really evaluate that world from any segment of a video. This is really cool stuff. So this applies to data visualization, and I think for Southern, wanting to have some level of virtual reality. These data sets are put out in LAS, which is basically a LiDAR format, and or an OBJ file. But very cool stuff. Let me show you so you don't have to just hear me say that it's cool. So what you see here, this is just this specific instance. We did a drone flight of a transmission corridor again, and this data is captured in CartoVid. You can see where it's at. But what's really cool about this is, I'm going to go to the next slide here. We generated a measurable point cloud from this segment of video. We've done this for dash cams, which has been incredibly useful from a distribution veg perspective and from a pole height. It's amazing the amount of information that you can generate with these, that are captured within these point clouds. And this is all done photogrammetrically. The ability to generate measurements for this case, that that transmission arm to the nearest tree is roughly 46 feet. It's fascinating being able to select a segment of video and generate, if you needed to go out and do some level of evaluation or measurements or field verification. Did our vegetative guys actually do the trim to what we needed them to from a right-of-way perspective? Being able to capture that information and quantitatively analyze it through the platform is tremendously valuable. And yeah, so we've been incredibly fortunate to have some great large utility customers and partners here. And with that's it for me. Hannah, I turn it back over to you. Thank you.
Great, thank you so much. All right, so it looks like we do have a few minutes for some questions. I'm going to first start with Intel. Can you tell us a little bit more about your mixed media approach? What types of data do you need, as well as additional applicators?
Yeah, sure, Hannah. Can you hear me?
Yep, you're all clear.
Okay, great. So today, as far as the information that we can essentially ingest into our platform is pretty much most types of what we'll call visual data. So John had kind of mentioned, right, they're doing a lot of work on video and other things, but basically photos, which are standard digital photos, like colored photos, are red, green, blue, like that you take on your iPhone. Multispectral imagery, thermal imagery type photos. We work with, of course, LiDAR data point clouds, any kind of TIFF file format. So orthomosaic imagery that may be post-processed in some other tools. We can ingest that. A long list of visual type imagery is kind of like how we've classified it. I'm just trying to think if there's anything we kind of don't really handle today. I'd have to go look at all the specifications, but I would say most of the types of information that utilities are collecting today, kind of from a inspection and kind of reality capture perspective, we can ingest.
Great, thank you. All right, Karush, can you tell us more about the number of utilities that have implemented digital twins for nuclear, and also the number that have expressed interest in it? You don't necessarily need to give us names, but just about the number of utilities.
Yeah, sure. I know at least of 2 utilities, one in the US, one international, that has implement some form of digital twin. But again, as I mentioned, the definition of digital twin is extremely broad, because it can be for equipment or the operational staff. There's a lot of interest in general as part of different nuclear industry initiatives to reduce the O&M cost of existing plants, and of course the O&M cost of future plants, because for future plants, unlike the existing plants, they also have to cover their capital costs, and in order to be competitive in this market. So yeah, I would say that the interest is wide, but in terms of the numbers that have actually implemented some form, is very few.
Thank you so much. Okay, John, over to you. What additional data needs do you have to bring together the right information to be successful?
Well, that's a tough question. How do we define the success, and in what success in what manner? So I think one, we are largely optically driven with this tool, so we've got to have good information. We're only as good, our outputs and our tool utilization is only as good as the data that it can ingest, and the data that's captured, and that we generate our various analytics on demand from ultimately. So I guess the simple answer would be the best data possible.
Great, thank you so much. All right, guys, so that answers our questions from the audience here. We are going to go ahead and cut to break. We will see everyone back here at 12 Eastern time. We do have a great Incubate Energy panel coming up at 12 Eastern. See you back here at 12. Thank you very much.